A train leaves the station A traveling 40 miles per hour. If it is traveling towards station B, which is 120 miles away, but does not stop at station B, for each hour fill in the table. So after I've traveled 0 hours, how far am I from station A, from station B, and how far have I traveled? So this is for each hour that I've traveled. Alright, so let's just make sure we're thinking of this right. So we have a train that's going towards station, it's leaving station A, so we're at station A, and it's going towards station B. And this distance is 120 miles. And it's traveling at 40 miles per hour. So that's the rate, and this is the distance, 120. Well, I know if it's going 40 miles per hour, every hour it travels 40 miles. So I should be able to logic my way through this. So after 0 hours, it's just about to leave, so it hasn't left. It's not any distance from A, and it's still 120 from B. And maybe I'll leave this last column for the end. Now, the distance from A is, after 1 hour, it's gone 40 miles. So it's 40 miles away from A. And it's gotten 40 miles closer to B, so it's 120 minus 40, which is 80. And after 2 hours, it's gone 80 miles away from A. And so now it is 80 miles closer to B, which leaves it 40 left to go to B. And then after 3 hours, it's gone another 40 miles, so it's 120 miles travel. And then it's gone 120 towards B, which was 120 to start with. It's at B after 3 hours. But now, station 4, hour 4, after 4 hours, we've gone 160 miles, and as you can see there's a pattern here. We keep adding 40, so I'm just going to keep adding 40 here. But now I've gone to 0. I'm not going to go to negative 40, right? Because how far am I away from B after this amount of time? Well, I've gone 160 miles, so I'm 120 plus another 40, so I'm now 40 miles past B. And then after 5 hours, I've gone 200 miles, so 120 was B. I've gone another 80 past it, and then another 120 past that. So those are how far I am from things. And you'll notice that, A is a straightforward, pattern. I'm adding 40 each time I go up. B, however, seems like I'm subtracting 40 up to here, but then I add 40 going back up. So there's an interesting pattern there that's going to come up over and over and over in this course. But the total distance traveled, well, hopefully you'll see that that's no different than the distance I am from A. The total distance I've traveled is these units. Even though my relative distance from B changes, my distance from my starting point is the same. So now, let me zoom out so we can see this all. On the number line below, mark where the train is at each hour. So if I start at station A, suppose A was my 0 point. So I'll count 0, my starting position is 0. And I'm doing everything relative to A. Fill in the values. Okay, well, let's see. In hour 1, I'll call this 1. I'm there. Hour 2, I'm there. And so, this is 40 away from A. 80 away from A. Here I'm at 120 away from A. 160 away from A at hour 4, hour 5, I'm 200 away, and on and on. But what happens if I start thinking of B as 0? Well, at hour 0 then, I am negative 120, right, is my position. At hour 1, I'm at negative 80. Hour 2, I'm at negative 40. Then I'm at 0. And then I'm at 40. And then I'm at 80 in hours. Let's see, this would be 3, 4, and 5. So you notice that my position from B and A are, the where I am differs depending on where I'm starting. So I paused the video, and just to save us some time, I wanted to talk about what these functions look like if I graphed distance from a given station versus time. The blue line represents from station A, and the red from station B. Now the blue is should be a straightforward line if my grid was a little better. It would just be going up 40 and over 1 every time. So this we would call a linear equation, because it should form a straight line. On the other hand, the distance from B forms this V, and we call this function the absolute value function. Now the absolute value function, absolute value can be represented by 2 bars around something, so like the absolute value of x, or the absolute value of negative 2, for example. And the absolute value just talks about what the distance is away from a given point. So the distance that we are from B always stays positive, right? So that's one of the things, is distances are always positive. And so when we're finding the distance away from a place, you'll notice the distance from B went down to 0 and then went back up positive again. We never said we were negative 40 away from B, because even though we were 40 away from B in different directions from a positional standpoint, right, just like when we were representing position, we were at some point negative 40 away from a positional standpoint. Our actual distance was never negative. And so absolute value is saying the distance away from a given point. So for example, the distance I am away from any given from station B at any given time was represented by this column. And this absolute value function we're going to get into deeper, but the big idea you need to understand from this problem is that distances are always positive and can be represented by absolute value. And in fact, this function, I could say that the distance is equal to the absolute value of the time minus 3. Let's see, so it's shifted over, and then I go over 1 up 40, so it's multiplied by 40, so this would be 40 times. And you can see that this works. We can try some values here. So if t is 1, then we would have 40 times 1 minus 2, or sorry, 1 minus 3, which is just 40 times the distance away from 0 that I am at negative 2. And at negative 2 on the number line, how far am I away from 0? Well, I'm 2 away from 0. Let me just show you that again. So if I'm 0 here and I'm at negative 2, the actual distance I am away from 0 is 2. So the absolute value of negative 2 is 2. So this just becomes 40 times 2, which is 80, which is exactly where I am away from B at time 1. I'm 80 away from station B. So we'll get more into these functions later, but the key idea here is that distances can never be negative, and that they can be represented by the absolute value of that distance, or of the position.